Welcome to Calbeckistan, where anybody can learn math. My name is Mr. Calbeck. I'll be teaching your lesson today. We're going to be talking about simplifying rational expressions. This is the first video in this series, so if you are jumping into rational expressions, this is the place you should start. Rational expressions, if you've heard that term, rational comes from the word ratio. Ratio means fraction. So if you ever see something that says rational expressions, rational functions, that means big, ugly fraction. And what we're going to do in this video today is I'm going to teach you how to simplify this. We're used to simplifying regular fractions, but we're going to simplify these big, ugly ones today, get them as small and as neat as possible. What I'd like to do in my videos is make sure that you understand why things are the way they are. So before we talk about this really big, ugly one, we're going to talk about some small, simple ones. If we can understand what we're actually doing in the small cases, it'll help us remember how to do simplification with these big ones. So here's a nice small fraction. If you wanted to simplify this, your elementary school teachers probably told you to divide the same number on the top and the bottom. And they're right, sort of. If you divide these by 4 on the top and the bottom, it's the biggest number that you can divide on the top and the bottom, you end up with 3/4. That is the simplified version of this fraction. You can always tell if you've simplified something correctly if you see that the resulting answer is equivalent. Equivalent is a fancy word that means equal or the same. So if you want to see if these two are equivalent, we can just check them in our calculators. You can type in your calculator, this one, and it will spit out 0.75. If you type this one into your calculator, it will also spit out 0.75. So that means that you've done this correctly. These are equivalent, you've simplified right. But there's a danger in this that gives a lot of people confusion when we get into more difficult fractions. And that's the way that your teachers have taught you this. Because you seem to think that you can do the same thing to the top and the bottom. But that's actually not right. You can't do the same thing to the top and the bottom. The golden rule of math, which I've taught in my other videos, says this.
That which you do to one side, you must do to the other side.
Notice the golden rule talks about sides. Doing the same thing to the top that you do to the bottom has nothing to do with the golden rule and will get you into big trouble if you're not careful. For example, we could add or subtract the same number to both sides, or to the top and the bottom of this fraction, and it will change it a lot. We know again that this should give us 0.75. Look what happens if we subtract the same number from the top and the bottom. I could subtract 13 from the top, and I could subtract 13 from the bottom, and let's see what I end up with here. 12 minus 13 gives me -1. 16 minus 13 gives me +3. -1/3, if you type that in your calculator, ends up with -0.3 repeating. These are very different. I went from a positive to a negative. They're not equivalent. You cannot, and I repeat, you cannot do the same thing you do to the top that you do to the bottom. That is not going to work. These are not equivalent. The thing that makes division different is that we're actually doing a little bit of a hack. And your elementary school teachers probably didn't even know this, so don't blame them for not teaching it to you. But there's one number that you can divide anything by that doesn't change it. You can divide by 1. And notice again what I did here is I divided by 4 on the top, and I divided by 4 on the bottom. 4 over 4 is a really creative version of 1. I like to draw a big 1 around these. So 4 over 4 just gives you 1. That's a really important idea. Because what you're looking at here, when you divide by 1, is the exact same number. You don't change it if you multiply or divide by 1. So let me show you exactly why this works here. So 12 can be rewritten as 3 times 4. 16 can be rewritten as 4 times 4. So 12 over 16, it's the same number. But notice here, there is a secret ninja 1 right here. I call them ninja 1s because they're invisible, just like ninjas, and they'll stab you in the back if you don't see them. So again, this is a big 1 here. So whether you multiply by 1 or divide by 1, you're not changing the fraction. Now this second option is really what we're going to be doing here in our rational expressions today. If we realize that we can split the number up into the things that multiply to make it, so 3 times 4 gives you 12, we call that factoring. You've done it a lot in math since your elementary school years, where you've taken a number and you've multiplied, or you've factored it to find 2 numbers that multiply to make it. So we can do that with our big, terrible fraction. What we can do is look for these big 1s. That will, in fact, cancel out and simplify our fraction. So let's jump back into that last question here. I'm fast at this. So we've got this here. What we want to do, we want to factor everything in order to look for those big 1s, because big 1s will cancel out. So what we can do here is we want to factor the top. If you want to look at some other videos that I've posted, you'll see some primers and a whole series of videos on factoring. But hopefully you remember how to factor this. It gives you x plus 3 and x plus 4. Again, if you can't factor in this unit, you absolutely need to be able to be good at it. You need to be fast at it, or it's going to be a big challenge. You're going to factor more in this unit than any unit in all of your mathematical career. So just keep that in mind. If you're not good at it, recommend you go take a look at my crash course on factoring. So x plus 3 and x plus 4. Down here, we've got 4x plus 16. This can factor. It's a little different, but easier. We just look for a common multiple. Both of these are divisible by 4, so I can rewrite this as 4 times x plus 4. You can think about it as undistributing a 4 from both terms. You can check to see if you factored correctly by multiplying that 4 back in. It needs to give you what you started with. All right, now let's go ahead and rewrite this and see if we can find any big 1s. I am pretty fast at this. So, hopefully you can see a big 1 show up in this problem. See if you can find it. Nice job. Hopefully you saw here that you have x plus 4 over x plus 4. What I've really done here is I've multiplied this fraction by 1. Since I'm multiplying this fraction by 1, I can divide it out by canceling it, and there's nothing left over. I hope you guys have fun drawing these big 1s. So what you're left with here is x plus 3 over 4, and that would be your answer, the simplified version of that fraction. It would be equivalent to the one that you started with. And again, we found that by factoring and looking for big 1s, because you can divide big 1s without changing your fraction. All right, that's a great example. I'm going to look one more, give you some places to, some pitfalls to avoid. All right, we can look at this one here. This problem, we're going to see if we can simplify this, but I'm using this problem to show you what not to do. Okay? As a math teacher, I grade a lot of tests, and this has got 2 of the errors I see most commonly that people do. So let's look at this here. This is the single most common error, and if you make this error on your test, you'll probably end up failing it. So please don't do this. But I'll see students do this. They see there's an x squared on the top and an x squared on the bottom, and they'll draw a big 1, and they'll be like, yeah, Calbeck, it's a big 1, I canceled it. It doesn't work. Remember, you can only multiply or divide by 1 without changing the fraction. Here, this big 1 is being added to the top and the bottom. Positive x squared plus all that stuff, and another positive x squared here. Since it's being added, remember, we can't add the same thing to the top and the bottom. That completely changes the fraction. So you can't cancel this out. The only way you can cancel it out is by multiplying by 1, which is why you have to factor first. I see a really similar thing with the 20s. People will look at the 20s and they'll simply cancel them out. You can't do this. You can't cancel out the 20s. Again, they're not even doing the same thing to the top and the bottom. There's a plus 20 here, a minus 20 here. It's not even close to making sense. Again, the only thing you're allowed to do is to multiply or divide by 1. If you add or subtract, you end up with big problems here, and you're going to get the wrong answer. So please, please, please do not make this error. What you need to do is to factor everything. So let's go ahead and do that. Go ahead and press pause. Maybe you can practice your factoring on this one. See what you come up with. Okay, we see here we've factored everything. And you actually, in this problem, you can't simplify anything. Even though it looked like you could at the beginning, because they were really similar in the top. You had an x squared and a 20 in the top, and an x squared and a 20 in the bottom. Even though they look similar, nothing actually cancels here. Because when we factor everything, there isn't a single factor that's the same. So this would be as simple as you can make it. In this problem, you wouldn't have to simplify at all. Again, please be careful as you do this on your test and not make these errors. I'd recommend you can watch the next couple of videos in my series if you'd like to learn how to multiply, divide, add, subtract these rational expressions.